looking at this integral then and having in mind the table of standard integrals, and it's exactly the one you have in the exam, the one that I'm interested in, I'll put this into the note so I can play with it. Let me. A bit weird, but never mind. So the one I'm interested in is this one. But the inverse becomes the log, the natural log of x. This first one, I suppose, is to do with this. Add 1 to the power divided by the new power is the first one. So actually this becomes just x. It's like 1 lot of x to the power 0. And so when I add 1 to the power, it becomes x to the 0 plus 1 is 1, i.e. the x reappears. So a constant, the x when you integrate it just reappears, or the t, whatever the variable is. In this case I'm integrating with respect to x, so it'll just be x plus. Now if we look at our table of standard integrals again, here 1 over x is log x plus c. So thinking about this is like 3 times 1 over x. I think of this 3 times 3 over x plus 1. We talked about this before, can be thought of as 3 times 1 over x plus 1. So the 3 stays in front, and then it's just log of x plus 1. So it becomes 3 log x plus 1. We've got to be a little bit careful what the number is underneath here, this x plus 1. So as a little aside to this, I'll just run through what's going on here, because actually the standard integral isn't telling you that it's just x underneath here, and we've got not x but x plus 1 or x minus 3, so it's not quite the same. So remember what we did in this case, we actually let u equal x plus 1 and used algebraic substitution integration by algebraic substitution. So it all starts to get a little bit scary because of all these different techniques you've got to include. And I'll just show you this method and remind you all, because it's useful for revision later anyway, and point out that actually in this particular case there's a shortcut to work out what the answer is. So I'll point that out as well. So let's just look at this integral of 3 over x plus 1 in more detail. So the integral of 3 over x plus 1, that's the same as 3 times the integral of 1 over x plus 1 that we've already talked about. I can think of that 3 as being separate. I've got a standard integral, and the standard integral is that the integral of 1 over x is log x plus c. That's the standard integral I'm going to use. But it's not x underneath here, as I've already mentioned, it's x plus 1. So what I do is I let u equal x plus 1. And then, if you remember, I differentiate that. And in that case, that just becomes 1. Because the differential of x is just 1 and the constant disappears. So, du equals dx. In fact, if we bring the dx up here, because that's what we actually do, we bring the dx up here, so that's here, and the 1 down here, so actually we've effectively got dx equals du over 1. In other words, whatever this number is goes underneath, if you remember us using this idea. And so the integral becomes 3 times the integral of 1 over u times du over 1, or just du in this case. which is 3, what's the integral of 1 over u, standard integral, log u. Replacing u with what we set it to be, which was x plus 1, 3 log x plus 1, which is what we had. Now, what's the shortcut that I mentioned? When I come to this bit, and I let u equal this, and then differentiate it, then when I differentiate, I get a number, and the number is the number that's in front of the x term. So, if this hadn't been x, it had been 2x, for example, that would have been a 2. Oops, that would have been a 2 here, so there'd have been a 2 underneath. If that had been a 3, there'd have been a 3 underneath, and so on. So in other words, the answer would have been, when I integrate, du over 2, or du over 3. So there would have ended up being a 2 underneath here, or a 3 underneath there, or whatever the number is in front of the x term would have gone underneath in the final answer. So the shortcut is to look at the integral and say any number on top just goes outside the integral. Any number in front of the x underneath goes underneath. And in this case, in that one and that one, it's a 1, so there won't be a number. If it's not x, but it's x squared, or x cubed, then we're in trouble, because you remember the algebraic method here, like substitution only works if x has disappeared. And if I were to integrate, if that had been x squared and I differentiated, I would have 2x and it wouldn't have disappeared, unless there'd have been an x on top that would have cancelled with it here. So in the exam, I'm going to make sure that that doesn't happen, or that it's particularly aimed at algebraic substitution, in which case that's what I'm testing. Okay. So that means with inspection we can do the next one. It's minus 2 log x minus 3 between 4 and 6. And now what I've got to do is put in the numbers. The top first and then the bottom first. So I just on my calculator work out what is this function when x equals 6, what is that function when x equals 4, and subtract one from the other to get the answer. So if you want to just finish that off by putting those numbers in. Remember the terminology. We can use curly brackets and then put in the first limit, 3 log what is 6 plus 1, 7, minus 2 log what is 6 minus 3, 3. So that's the first one, and then we subtract the next one. So if you want to just finish that off, work it out. I'll just jot the answer down below. And so we end up with 0.81, which agrees with the text, luckily.